This is video 3 for A-14, so we're on the very last page, and we're going to be taking a look at solving logarithmic functions. So they're called logarithmic functions because they have a log of something expression that has a variable in it. So the first two are going to be pretty straightforward. We're solving for x, and notice that x is kind of embedded in those parentheses, and it's embedded behind the log, so we need to get rid of the log. So one way to do that is to change it into an exponential function. We know how to do that. So the base is 3. The logarithm is the exponent, so this becomes 3 to the second power is equal to 2x minus 1. So it's sort of a little swoopy thing. So start here, swoop over here, swoop back over here. So this is equal to 3 squared is equal to 2x minus 1. Well, 3 squared is 9 equals 2x minus 1. Adding 1, that means 10 is equal to 2x, and so that means x would have to be equal to 5. And you can see that if I sub 5 back in here, I get the log base 3 of 10 minus 1, which is 9, is equal to 2. And you should be able to check that and see that that's correct. The next one, remember, think of this as the log base e of x minus 1 equals 3.14. So if I put that into exponential form, the base is e, so it's going to be e to the 3.14 power, has to equal x minus 1. So if we want the exact answer for this, we don't care what the decimal approximation is for this. I'm just going to add 1 to both sides. And so I'm going to end up with that x is equal to e to the 3.14 power plus 1. All right, the next one's a little more complicated. We have logs in two different expressions, but notice that it's the sum of two logs. They're both base 10 logs. So we know that the sum of the two logs right here came from a product. So we're going to treat this as one of them, the functions, and this as the other. So I'm going to end up with log of, so remember that I get x times x plus 3. So this becomes the log of, technically, x squared plus 3x equals 1. Right, and now that we've written it as a single log, now we can write it in the exponential form. So this becomes 10 to the first, and that has to equal x squared plus 3x. So this becomes 10, well, I'm going to subtract the 10 from both sides. So 0 equals x squared plus 3x minus 10. And so that means that this is the same as x plus 5 times the quantity x minus 2. So that means either x is negative 5 or x is equal to positive 2. Now, for this one, if we notice, subbing the negative 5 back in is going to be problematic because the problem says we want the log of x. Well, if I sub negative 5 in here, I'm taking the log of negative 5, and remember, I can't take the log of negative numbers. Log graphs just look like this. There are no x values in the domain that are negative. So x equals negative 5, or x equals 2. Well, anyway, that one has to get eliminated. X equals 2. If we check that one, we can see that we end up with the log of 2 plus the log of 5, and we want to know, does that equal 1? Well, this becomes, because it's the sum of two logs, that becomes the log of the product, 2 times 5. So this becomes the log of 10. And the log of 10 we know is 1. So what that tells us is that this this works, all right? And that's what we wanted to confirm. So x equals 2 is the correct answer for that one.